Good morning, and thank you for the introduction. It's great to be a part of this event. As you just heard, I'm Dr. Cory Kidd. My current role is as founder and CEO of Catalia Health. But I've been working at the intersection of advanced technology, including artificial intelligence, robotics, and aging for about 25 years now. So this is an area that I have dedicated my career to. I think at this point in time, we're very obviously at an interesting point in time when it comes to artificial intelligence and a lot of recent advances, which you've certainly heard about. So I do want to try to incorporate some of that into what I'm going to talk about over the next 15 to 20 minutes, but also give the broader context of where some of this technology has come from over the last couple of decades, where it's really entered practical application today, and what the opportunities are for us in the very near future. And so, if we think about what the importance of using advanced technology in elderly care, in rehab care, in kind of overall challenges of aging, the things on this slide, I think, are very obvious to everyone listening here. So I'm not so much going to talk about that because this really drives everything that we see happening in this domain overall. But I want to talk just a minute about my motivations. Again, I've always worked right at the intersection of cutting edge technology and healthcare. And I've always seen an enormous opportunity to take things that are cutting edge, right? New to the market, coming out of research labs and are not yet broadly commercialized, and find ways to get them into the healthcare ecosystem in a way that can really make a difference to a large number of patients. And I think that with the technology that we see continuously advancing, it inevitably will enter healthcare. It will inevitably enter the aging space. But the faster that we can do that, the more people who are going to benefit because of the things that we see on this slide in terms of demographics, challenges, and opportunities. So this is where I've spent my career, and to situate a little bit about what I've done before I transition into first some of the broad applications, and second into some of the specific things that I have had the opportunity to build over the last couple of decades. I'll start with my background. So my undergraduate degree was in computer science. That was at Georgia Tech in the United States, with a focus on artificial intelligence and human-computer interaction. One of my fellow panelists in this workshop, Dr. Wendy Rogers, may not remember me, but I had the opportunity to work with her a little bit almost 25 years ago when I was helping to build something called the Aware Home at Georgia Tech, which was a residential laboratory environment for exploring opportunities of using cutting-edge technology, specifically around the question of aging. That's a lab that a number of faculty built in around 1999 and 2000. I was fortunate to be in the position to help run the lab, to help build the lab, and to actually live in it for a little while. But then a little over 20 years ago in 2001, I left Georgia Tech and went to pursue additional education. So I went to MIT, where I did my master's and PhD in the media lab, again, at the intersection of AI and psychology, as well as applications in medicine. So I spent about 6.5 years at MIT. And the last 3 years, I actually split my time between there and Boston University Medical Center, where I had the opportunity to work with Dr. Carolina Povian in endocrinology, and was able to take some of these applications of artificial intelligence and robotics and put them directly in the hands of patients. I'll talk about some of that in just a moment. Since then, in the last 16 years, I have founded and run 2 companies. The first one was really directly commercializing that academic work in endocrinology, so in particular in diabetes and weight management. That company was actually based in Hong Kong at Science Park, so I was fortunate to spend about 6.5 years living in Hong Kong. I've now been back in the United States in the San Francisco Bay Area for the last decade, where I have been running a company called Catalia Health, again, applying artificial intelligence and robotics, this time broadly across chronic care management. And in a couple slides, I'll start talking about a little bit more about what we're doing and the experiences of our patients and clinicians that we have the opportunity to work with. But before we jump into the specific things I have done, I'd like to give kind of a broader view of 4 of the key areas where there is already commercialization in robotics and or artificial intelligence. So just starting at the left of the slide here in elder care robots. This has long been an area of research. One of the early robots you can see in the forefront of that picture, the Paro robot. This has been used in elder care facilities broadly, and more specifically in dementia care facilities worldwide for about 2 decades now. So there have been some very interesting results in using this to help people, as they age, try to reduce the progression of dementia. There are other robots like Now in AO from a French company, Pepper out of Japan, that have, some inroads into healthcare. I think that while there are a few interesting examples, we have a long ways to go in terms of elder care robots. There are some newer ones that are being used, like the Meibu robot that I'll talk about in just a moment that we've developed at Catalia Health, the LEQ robot from Intuition Robotics. Some of these are starting to make larger advances worldwide. There are definitely big opportunities here. The second category is rehabilitation robots. And this, along with the third, surgical robots, are in some senses, the more established robots in the healthcare domain. So rehab robots, we have things like what Dr. Hugh Hare is wearing in that second picture there, some robots that his lab at MIT have made. He's also spun out a company called Bionics Medical Technologies. There are partial body to full body exoskeletons, so essentially robots that you can get inside of and wear, from companies like Exobionics and others. So rehab robots have been on the market for a few decades, and we're seeing a lot of use of those now. Similarly, surgical robots have been around for a couple decades as well. The best known one is probably the Da Vinci robot from Intuitive Surgical that's been out for I think close to 25 years at this point, and has performed a lot of surgeries alongside the doctors who are controlling these devices. So these continue to evolve. We continue to see advances. I expect that even in the coming 6 to 12 months, we'll see exciting new advances in this kind of technology. And the last category is not robotics. It's in some senses kind of a more traditional technology in terms of home monitoring, remote patient monitoring, but the idea of putting sensors on a person or in the home and helping to alert their care team, whether that's a doctor or a nurse or someone else remotely. But the reason I include this here is recent advances over the last several years in artificial intelligence have allowed us to start doing a lot more with this kind of technology. So for example, Philips, a large international company with a sizable presence in Hong Kong, although more their lighting division, has their CareSage program, their service that is AI powered. And we're seeing more and more of these come onto the market from both large established companies like this, as well as a lot of startups that are doing some very interesting things in this space. So when we think about aging care and an older population, this kind of technology can be a great starting point that's accessible to many people. Many of these programs, services, pieces of technology are relatively low cost now. And many of them you don't even have to buy. You can pay for a program and those devices come as part of it. And these are really starting to reach scale in many places around the world. So we'll maybe come back and touch on this if we have a minute at the end or during the Q&A period. But again, a lot of things happening overall in terms of artificial intelligence and robotics that's actually on the market today. And some of these things have been established for some time. So I want to switch gears a little bit and talk about what I have been building for about 18 years now and what we've commercialized at Catalia Health over the last 9.5 years. And so at core, what we create are care management programs for patients who are dealing with particular conditions. You can see at the bottom of this slide some of the areas that we've worked in. So we've launched a heart failure program in collaboration with the American Heart Association, so doing work in cardiology. Some of our biggest growth in the last few years has been oncology, helping patients with various cancers to better manage their medication regimen and check in with their care team. We've done a lot of work in immunology over the last decade, particularly with rheumatoid arthritis patients, and making sure that they can successfully stay on their medication and overall improve outcomes. My background, as I mentioned earlier, was in endocrinology, so helping diabetes and weight management patients to better manage the course of their disease and try to prevent progression or at least slow it down. And so again, what we've built are care management programs. And so what that means is, first, a lot of AI. And so when we're interacting with patients, we're often replacing these big call centers that are overwhelmed, and they may be able to talk to each patient every few weeks or typically every 1 to 2 months. So the patients don't get much interaction. With conversational artificial intelligence, that is allowing us to talk to any patient whenever they want. And so it's available 24/7 for interaction. And what we've seen is we go from, with a traditional program, maybe 5 to 7 conversations a year with a patient, to talking to our patients on average more than once every other day. So it's just a much greater level of interaction, which is beneficial to our patients. They love this, something that's always available whenever they want, but also beneficial to the clinicians, the care team. They're able now to get a sense of what's happening across their overall patient population and understand for any particular individuals if they do need to do some outreach and follow-up. So what's important to note here is this is not a replacement for those clinicians. This is augmenting and filling in the gaps. And I think this is one of the really exciting opportunities for this kind of technology. We can start to provide a level of care that was next to impossible before because we simply don't have enough people to interact with patients on the frequency that we would love to be able to. And so the last part of this I'll talk about is fairly obvious from the slide, this cute little robot that you see. So we call this one Maybu. And so all of this AI lives in the cloud, which means we can deliver these conversations to patients through different interfaces, whether it be as simple as a smart speaker or a text messaging program, supporting an app where we deliver those conversations, or an interactive robot or social robot like Maybu. And we prefer to do that last one, not for a technological reason, but for a psychological one. And the easy way to explain and think about this is this would be a little bit different conversation if we were all in the same room, right? It's great if we can have a conference and we're all face-to-face, and particularly if we can have a one-on-one or a small group interaction. That's different than something like this over a screen, right? We all get that intuitively. That's why so much of business is still done face-to-face, and why we're all trying so hard to get back to that after the challenges of the last few years. Now, contrast that with what we're doing now, or a phone call, or if I just recorded this on audio and you were listening to that, it's different, right? So we get that intuitively, but it turns out that those differences carry over into the world of technology, where when you put a physical device like this cute little robot that can look you in the eye while it's talking to you, it turns out that you get a psychological impact very similar to a face-to-face conversation with another person. And so when you combine these two pieces of technology, what's today a relatively simple robot that can move around, look around, make eye contact, with the artificial intelligence to generate a conversation on the fly that's tailored to that patient, and you put these things together, that's when we get the best outcomes. That's when patients like this, that's when patients use this, and we get the longevity that we really care about in aging and other healthcare applications. And so, some of the key things that we've seen over the last 17, 18 years now of deploying these to various patient populations is, one, patients love them. Like I said, having something that's available 24/7, not having to go sit in the waiting room and see a doctor, wait on hold to get a call through or to get a call back. It's always available. It's tailored to each individual. The artificial intelligence lets us talk to each patient as a unique individual. And like I say on the slide, the responses have been overwhelmingly positive. One of the fun things that we get to see is patients will seek us out. They'll dress up their robots. They'll send us pictures. They'll send us letters about how much they love it and how well it's working for them. The second point, though, here is also critical in that clinicians find it easy to use. And so one of the things that we've done a lot of work around is trying to ensure that we always fit into existing workflows. So we're not coming in and saying, oh, look, here's a robot we're giving patients. Now here's this new system you have to log into, you have to program it, you have to do this. We try to do none of that. We work with our customers, whether it's a pharmacy, a clinical practice, a clinical trial group, and try to fit all of the data we get into their existing workflow. And I think this is really important as we think about the adoption of new technologies, whether it's robotics or artificial intelligence or many of the other things that we're seeing come to market. We have to fit in with existing systems, programs, and workflows. We've got to make sure that we don't disrupt the lives of all the healthcare professionals because they're already overwhelmed, right? Our job when we're building and implementing and deploying these kinds of things is to make sure that we make their lives easier and improve patient care. And finally, I think the critical point is we can show that we improve clinical outcomes. You know, whether that is better indicators for heart failure patients, improving medication compliance, reducing loneliness. There are a lot of exciting things that we're seeing with this kind of technology. And so as we move forward, there are a number of practical considerations that are incredibly important when implementing artificial intelligence and robotics. I've already touched on some of these, but I want to take a minute here to talk about ethical concerns. I think this is something that we're starting to hear more and more about in the last 6 to 12 months as advances in AI have become more prominent. And I think that this is one that is incredibly important, being able to understand where we are fitting these kinds of technologies into patients' lives, into clinicians' lives, into the lives of families of patients, and thinking several steps down the road very critically about how this will be used, what the potential challenges and risks are, and ensuring that we do everything that we can to mitigate those and to educate all of the users on this. And that starts to bleed into this training and support, ensuring that everyone knows what this system is and how it's used. One of the advantages of using cutting edge technology is that we're getting better and better at being able to, in some sense, encapsulate the complex parts behind user interfaces that are very simple. This is another advantage of using our robots. We can put these in a patient's home with no setup instructions other than take it out of the box and plug it into power. That's it. Everything else is through conversation. If the patient has a question, they can talk to the device. As AI continues to advance, we'll see this in more and more places in the coming years, and really even the coming months with the speed it's going at. And the last one I'll spend a moment here on is regulatory compliance, right? In every market in the world, healthcare and medical devices are very well regulated. Working with regulators early on is very important as we start to deploy these new technologies. We have to start from the conceptual stages, and that's how we get these things out faster, by collaborating with the regulators. The last point I've already touched on, right? Integrating with existing workflows, and that's very important. And I think the last thing I want to say about this slide is, you know, for everyone who's listening, regardless of, you know, your background and current job, if you're working anywhere in the aging space, you absolutely have a voice to contribute to all of these conversations. These are very complex topics. Some of them certainly border on the technical, but by no means are any of these purely technical conversations. Some of these are absolutely a part of existing healthcare and how do we fit in. But everyone who has an opportunity to participate in the conversations around any of these topics, you know, and I think the entire industry would love to see that, because really that's how we advance all of this technology and get it into the hands of patients in a way that's going to make a positive difference as quickly as possible. And then I'll wrap up on this note about future directions and policy implications, because I think that these are very much intertwined. And again, coming out of those discussions on the previous slide. One of the things that we're already starting to see and will continue to accelerate in the coming years is personalized care, leveraging this technology to really adapt to each individual patient. We've seen more and more of this in artificial intelligence attempts over the last few decades, and more successful deployments of this kind of technology in recent years. And we're going to see a lot more of that in the near future. Again, I'll come back to the fourth item on that earlier slide of examples, remote monitoring. The capabilities for remote patient monitoring today are higher than they've ever been. This is an area that my career has touched on for nearly 25 years now. And I'm very excited about what is being deployed and we can readily leverage in applications around aging today. And again, policy consideration, right? When we think about the demographics and the technology and the implications of this, this is an important place that all of us need to take part in. So again, thank you for having me as part of this event today. I am very much looking forward to the questions in the next few minutes, and please do reach out and follow up with me after the event as well. Thank you.
Thank you, Cory. And let us take the question from our online audience. So the first question is, although AI or robot becomes more popular nowadays, elderly or patients would still prefer human touch. Can Dr. Kidd share your experience on how to encourage patients and their family members to accept robot companion? Hi, Dr. Kidd.
Hello, thank you. In my experience, it's actually very easy. The basis for the kind of technology that I've always built is around psychology, right? How do humans communicate with one another? So we don't start with the technology, we start with human communication. And I think the other part that I mentioned a few minutes ago that's relevant is we're not trying to replace people, right? We're trying to augment people and fit in. So it's not an either or choice. It's not, you can have your doctor or nurse or a robot and AI. It's here are some additional tools that we can provide to the aging population, to the elderly, that augment what their doctors, nurse, and other care team are doing. And when you make these very easy to use, very intuitive to understand, and available and accessible 24 hours a day, 7 days a week, we found that people adopt them very readily.
That's amazing, and you're right. And this, because in the end, it's how men use the technology rather than not technology use men. So it's important to introduce the robots into the human rather than using other things to introduce it. Thank you. We have another question. Patients have their own medical and treatment routine. Would you please elaborate more how to integrate AI robots into the existing care workflow?
Absolutely. I mean, if we think about any individual's journey going through treatment, everyone is unique, of course, right? But the general pathways that we're following, the treatment guidelines for certain conditions or combinations of conditions are shared. And so we can leverage those and build that into the AI, along with the capability of integrating specifics from a patient. And I think we're at an exciting point in time. We've talked about personalized medicine for a decade or two now. We've certainly made progress on that. But with some of the recent advances in artificial intelligence, we can learn not only about, what the right treatment regimen is for a certain patient. Do we adapt a medication, or do we change a schedule, or do we do a test differently or at a different time? But we can also understand how to talk to this specific patient, right? And this goes back to that psychology I was talking about a moment ago. And there's an analogy in medicine. What we usually call this is good bedside manner, right? And we mean a clinician who's better at connecting to that patient in front of them. Now we can do the same thing with AI. And so we can take these tools that, again, are adding on to what we were already doing with our doctors and nurses and other clinical staff, and making them really tailored to each specific patient and their needs.
Right. I think this is also how robot can help us to establish pattern, and then they can learn from probably patients with probably close symptoms or something, that they can learn from the experience they have gained from patients, which is actually helping to us to learn about the patients as well. There is another question from our NGO friends in Hong Kong. So how is the cost effectiveness considered for the implementation of AI technology or robot care? Is this still an option only available for relatively wealthy elderly in your experience?
You know, it really depends on the application. And I think I'll go back, like I usually do, to the human analogies, right? There are a lot of different levels of care that we can provide with people, from a quick check-in with the doctor virtually to an in-person appointment, all the way to the extreme of having, you know, in-home care all of the time. Similarly, technology is fitting in different places. You know, the cost of building the technology has dropped significantly over the last 1 to 2 decades. So we're not at the beginning of this anymore, right? These programs, these technologies are very much at the commercial stage. And what we're seeing then is opportunities, again, to integrate into existing programs in places at very low cost. You know, my previous company, I was based in Hong Kong. Now, for the last 10 years, I have been back in the United States, where we have rolled out nationwide programs with patients with a number of different disease states. And I think one of the exciting things for us at Catalia Health and what we're doing as a company is finding opportunities where the cost to the patient is always zero. So including this in a healthcare program, including this with a prescription or things like that, where there is no incremental cost to the patient. And we've gotten to a point where the technology is, again, incrementally getting less and less expensive, that allows us to start to introduce these things at scale and make them accessible to as many people as possible.
Right. Yeah. This help us to, if it is more democratized and more people are using it, and the cost should be less. There's one more question from the floor. You mentioned the data management in AI and robotics would be one of the future directions. Can you share the plan or next stage for your company on this?
Sure. I mean, there's a lot happening around that today, you know, not only at our company, but, you know, kind of across the healthcare technology ecosystem. You know, data management, data privacy when it comes to health is of utmost importance. I think the trend that we've seen is patient data stays private always. You know, for us, that doesn't get mixed with other patient data. That, of course, never gets sold. We're not doing any advertising, right? We're providing healthcare services. And so I think that's different from the broader technology industry. But at the same time, I think it's having an impact on the broader technology industry, and that we're starting to see more segments of it move in this direction. And, you know, like I was talking about a few minutes ago towards the end of my talk, you know, having everyone involved in this conversation, you know, reinforcing the importance of data privacy and privacy in general for patients when it comes to their health information is something that we can all participate in.
Yeah, it is also something that you should not give up no matter what. Like, that's why spending money on this and the cost will be much harder if you're protecting the privacy. One more question from the floor. So if Marble comes to Hong Kong, anything you foresee to prepare for localization and adoption?
So we've done localization in a number of places, and you know, there's a couple of main things. The obvious one is changing the language, and the tools today allow us to do that fairly readily. The other piece of it is sort of the story behind it, right? Mabu is a character, and you know, kind of has a background, and so we rewrite that story for different places so that it's more appropriate. You know, we always work with local partners who understand, you know, the situation and how a healthcare worker would fit in, what their background might be, and what's appropriate there. You know, someone local is always going to know better than a single company trying to do something worldwide, and so that's an important part of the localization.
That's amazing. We look forward for Marble to come to Hong Kong. Then they will be definitely our elderly here, or people using Marble will be feeling a friend, having a new friend in Marble. I think that's all for our questions today. Thank you, Dr. Kidd.
Thank you so much for having me.
Hello, thank you for joining me here today. My name is Wendy Rogers. I'm excited to talk to you about the potential of robots to enable independent living for older adults with mobility limitations. I direct the Human Factors and Aging Laboratory at the University of Illinois, and our focus is on successful aging. We define this very broadly. We include functioning effectively and independently, maintaining personal autonomy, retaining and enhancing abilities, managing health and wellness, and thinking about health very broadly, so to include chronic conditions as well as general wellness such as exercise and physical activity, and also participating in one's community. And so we do this by understanding the abilities, the limitations, the needs, and the preferences of older adults to contribute to the design of technology for older adults. But I want to emphasize we do our work with older adults. So older adults are engaged in all of the research that we do. And the goal is usable and useful products and systems. We also focus a lot on the importance of providing effective training and instructions, and the ultimate goal of optimizing deployment and introduction of the technology into the lives of older adults. Much of our research is conducted in this wonderful research facility we've recently opened on the University of Illinois campus called the McKechnie Family Life Home. LIFE is an acronym that stands for Living in Interactive Future Environments. And this space provides a simulated home environment where we can conduct research. We can also host teaching, learning, and design activities. It's a great place to enable faculty innovation, community engagement, industry partnerships, and healthcare provider collaborations. What I'm going to focus on today is our work with robots. And our university did a story on our research last year, and this is the cover of the story. It's called Home is Where the Robot Is. And I've provided a link to the story if you'd like to read more about it. One of the robots we're working with is called Misty. So we're focusing on both social robots and assistive robots. And Misty is a little bit of both. So it's a social robot, but it can actually assist with various activities. What's nice about this particular robot is it's market ready. You can buy it. It's fully programmable. It comes with some skills built in, but it also is something that you can design to be customized to assist with a range of activities. So we're using this robot to control various aspects of the home environment. And we're interested in the degree to which this kind of a robot, as a socially assistive robot, would be useful to older adults. And so in this first study, we're trying to understand the facilitators and the barriers for the use of the Misty robot. So I'm just going to show you a few short videos to illustrate how we're using the Misty robot.
How is your day going?
My day is going great. I went for a walk and I had lunch with my friends.
That sounds like a lot of fun.
How is your day going, Misty?
I'm having a fantastic day. Happy to see you.
So this video just provides a short example of how a person might engage with Misty as a social companion. We're also exploring the utility for health reminders.
Misty, when do I take my medication?
Based on your prescription, you have to take your medication at 5 p.m. this evening. Don't forget, you also have some medication later this evening. Would you like me to remind you later this evening?
Sure, that would be great. Thank you, Misty.
And then the third example is using Misty to control aspects of the environment.
Misty, could you please turn off the lights?
Sure, I can take care of that. Turn off lamp lights.
Thank you.
One nice thing about having Misty as a central point for controlling the environment is the older adult doesn't have to remember different key words or different wake words for different kinds of technologies in the home or different specific instructions. The person could just use the Misty robot to control various aspects of the environment.
Misty,
and so in this study, sorry, let me turn off the volume. So far, we're collecting data still with older adults, but they've been very positive about Misty. They like the appearance. They have a lot of ideas for how they might be able to use the Misty robot, and they find it to be very engaging. And that's really important. If we're going to use robots to support older adults, there has to be an enjoyment component. They have to want to interact with the robot. Another aspect of social robots is related to trust. And so I want to just show you one slide of data from a study that we recently presented. It's under review at a journal right now. And we were focused on the relationship between how sociable a robot appears and how likely somebody is to trust that robot. And so we presented older adults with various videos of different kinds of social robots. And we asked them to give a rating. How sociable do you believe this robot is? And then we also asked them, how much would you trust that robot to do a variety of different tasks? And what you see in the graph is there's a very strong relationship between how sociable they found the robot to be and how much they were willing to trust that robot. So this idea of sociability and trust for assistive robots is something that we really need to think more about. Now, not all robots are social. The other robot that I'm going to focus mostly on today is not really a social robot, but it's an assistive robot. This is an interdisciplinary project with a company called Hello Robot and an assisted living community called Clark Lindsay Village. And the grant is entitled Stretching Their Reach: Robotic Support for Older Adults with Mild Cognitive Impairment, Early Alzheimer's Dementia, and Mobility Impairments. I'm going to focus primarily on the mobility aspect of things today. Let me show you the Stretch robot. This is in the Life Home, where you will see the Stretch robot delivering to me, I'll be in the picture in a moment, a bottle of water. And what you can see illustrated in this is the mobility of the Stretch robot. It also is what's called a manipulator robot. It can pick things up, it can carry things, and here it is delivering to me a bottle of water.
Thank you.
One thing that's interesting is we're working with older adults right now in this robot, and nearly everybody, when the Stretch robot gives them something, they say thank you. It's not very social on its surface, but there is some level of social interaction. And I have some of the characteristics of this particular robot here that speaks to the scalability of using this kind of a robot in home spaces. It's low mass, it's contact sensitive, it's low weight, it's compact, and it's ready for development and autonomy. One of the key things about the company is they really want robots to be out in the world, and so they're working towards that goal. Here's a short video showing Stretch in action doing some household chores. One of the things you'll notice from this video is it doesn't necessarily do things quickly, but that's not really a problem from the older adults we've interviewed who have mobility challenges. They're not in a hurry to get things done generally. They just want things done carefully and with precision. And so this is just showing one example of how the Stretch robot might be used to wipe something. But if you think about it as wiping something on the floor, there could be a fall risk if something has fallen. So there's a number of different potential use cases for this kind of a robot. So one of the things we've been exploring at the Life Home is just some of these different activities. If you're a person with a mobility limitation, some of these different activities could be very useful to you. So delivery of an object, turning on a light. Imagine if you're in a wheelchair, that might be difficult to reach the light switch or reach to the back of the sink for the sprayer, opening cabinet doors. And so in a controlled environment, we've been exploring the potential for the Stretch robot. The other aspect of this research is in a much less controlled environment. We've been doing a participatory design field trial with the Stretch robot embedded in the home of Henry and Jane Evans. In 2002, Henry had a brain stem dissection. So as a result, he has very limited use of his thumb. He can move his head, but he is mute with quadriplegia. And Jane is his wife and primary caregiver. They're very much a part of our team for design of robots to support individuals with mobility limitations. Henry is really the extreme case of mobility limitations, but he happens to be somewhat knowledgeable about robots. So he's been a wonderful partner for us. And for the last several summers, we have put the Stretch robot in their home along with staff from Hello Robot and some of our students and postdocs. The way that Henry can control computers in general, as well as the Stretch robot, is through this reflective dot that's affixed to his glasses, and he can control, you can see his computer screen here on the right. He can input using a keyboard, sending emails, doing searches, but he can also control the Stretch interface. And what I'm going to show you is what his interface looks like. And this is one of the things he's been helping us with, is what is the easiest way for him to view the Stretch robot. It might not be co-located with him. It might be in the kitchen and he's in his bedroom. He needs to see where the robot is going and what it's doing. He needs to be able to control it. One thing we explored in this past year was also a way to save. You notice over here on the lower left, it says save the pose. So he could get Stretch to his bed, ready to do something, and then store that so that the next time he doesn't have to manipulate the robot next to the bed. He can just say, move close to the bed. So he's teaching the robot about what his unique needs are. We also explored with Henry, what do you want to be able to do with the Stretch robot? And one key thing is, I want to be able to feed myself. I don't want to have somebody next to me always feeding me. So let me show you the video. And Henry has a wonderful personality, and he enjoys working with our students on the use of the robot, as you can see reflected here. So he's doing this all himself. So he's controlling the arm of the Stretch robot all through his vision. And he's able to feed himself. Now, during the testing, you'll notice we had a researcher right there for safety reasons, but this is enabling us to explore the potential of this kind of a robot to give him back some of his autonomy. And I'm going to just show you a couple of the different activities that Henry has been doing with the robot. Another example is turning on and off the lights. I mean, just try to imagine yourself in Henry's position. I want to take a nap. I want to turn off the lights. I don't want to have to bother my wife or somebody else to come in and turn off the lights. And so we're working with an occupational therapist. And one of the things that occupational therapists do is they design tools for humans to be able to perform tasks. Well, our occupational therapist has been designing tools for Stretch to make it easier for Stretch to perform tasks. So if you look here, she's configured something on the light switch and something that Stretch is holding that will make it easier for Stretch to be able to turn off and turn on the lights. And this video is in real time. So again, you notice it's not necessarily fast, but that doesn't matter when it's providing somebody with autonomy to be able to control their own environment themselves. Another example is something that is an annoyance and a frustration to Henry, that sometimes he just has an itch and he wasn't able to scratch his own itches. Imagine how frustrating that could be. So you can see the tools that the occupational therapist has mocked up, just as we're exploring ways to make it easier for Stretch to hold the brush and for Henry to accomplish his goal of scratching his head. So you can see the different angles as he's able to do that. Henry reported to us that he has an itch maybe 3 or 4 times an hour. Well, how frustrating that might be if you can't scratch your own itches. And so Stretch is just enabling him to do that. Another example this last summer was Henry wanted to be able to play with his granddaughter. And so we set up a way for Henry to be able to play games with his granddaughter. This is really important, this idea of social interaction and engagement between family members. And you can see the opportunity for Henry to just be able to play games with his granddaughter. We explained to her that the stretch robot is an extension of her grandfather, and that really she's playing with him and he's just using the robot to interact with her. It was highly successful, and everybody in the family was so excited to see the 3-year-old and the grandfather being able to play together. Another example of social engagement is having friends over to play cards. So in the past, if Henry wanted to play cards with his friends, somebody would have to play his hand for him, took away his independence. And he likes to say that he's a winner and he beats everybody, and he can do that himself. So he's viewing his own hand with a holder that the occupational therapist made up. And then the stretch robot, when Henry's ready to play a card, the robot just picks out the card and plays the card. And so again, it's all about autonomy, independence, the ability to do what he wants to be able to do. This is still a research robot, so we're exploring how do we make these things happen in someone's home. So it's not a completely controlled environment. It's a space with carpet and people and pets sometimes, or children. How do you make sure that the robot is safe and that it can accomplish the goals that the users have? As you might expect, doing this kind of research takes lots of different participants. So in addition to Henry and Jane, we have the Hello Robot staff. We have my team at the University of Illinois. This one thing that's exciting about these kinds of projects is students are very interested in getting engaged. So we have postdocs, graduate students, and undergraduate students in this image here. And then I mentioned we're working closely with Clark Lindsay. Clark Lindsay is what's called a life plan community, where they have individuals who have independent living apartments or homes on the property, to assisted living, where they're getting some support for medication or meals, to memory care, where individuals have memory challenges such as Alzheimer's. And in the next year, we're going to be putting the stretch robot at Clark Lindsay and exploring how the staff members can utilize this robot to make their jobs easier and to support the needs of the people living there. So we'll be working both with the staff as well as with the residents. I want to share with you the words of Henry and Jane about the impact that this project is having on their lives. And Henry's words are that robotics in general have had a very large impact on my life, and stretch is an important link in the evolution of those robotics. Using stretch was surprisingly easy, showing how adaptable stretch is. Jane's words also, to me, are very striking about the impact of stretch. Robots have influenced Henry's life greatly. They gave him a reason to live. Stretch is the closest to improving Henry's life and therefore mine. I see stretch doing several things around the house to help Henry and me. Her second point I also want to emphasize. We have to ask ourselves over and over, why robots when a caregiver can do it 10 times faster? I see what it does to my husband mentally when he can do things by himself and is not dependent on anyone. This is huge because it translates to one's mental state. Attitude is the key to improving and moving forward. So these words of our users really convey to us the importance of these kinds of assistive robots for the lives of individuals. I want to share with you one program that people might be interested in that is engaged in some of this research that we're talking about, but also a lot of other research in the field of health technology. This is a new master's program we've developed. It's a 1-year intensive, 12 months, STEM designated program, and we have scholarships and fellowships for all of the students who participate in the program. We have an early deadline of December 1st, and I encourage you to check out our QR code here, and you can come to an information session and or register for an application workshop. And so students in this program get to do research in the Life Home, they get to work on some of our robotics projects, but they're also engaged in a host of other health technology related projects such as mHealth or wheelchair design or app development, wearables, broad range. And so if you're interested in the field of health technology, I encourage you to look more at our program. I will stop there and introduce you to my lab group. These are all of the students, postdocs in my lab. And I have my email address on the screen. I encourage you to reach out, ask me questions about the research that I've presented today. And thank you very much for your attention.
My name is George Demiris, and I'm with the University of Pennsylvania. And I will be talking to you today about different ways that we can utilize artificial intelligence technologies to support older adults who might be experiencing cognitive impairment. We are clearly in a new era of aging. Globally, we see changing demographics and workforce shortage to address the needs of this aging population, and an increased needs for older adults to stay at the residence of their choice, basically to age in place, rather than transfer to different facilities of care every time their healthcare needs change. And also we have an emerging focus on precision medicine. Precision medicine calls for collecting and analyzing large data collected on the individual's behavior, lifestyle, genetics, and environmental context. In other words, we are looking at understanding the whole picture, not just the assessment that happens during clinical encounters. And here's where behavioral sensing can actually play a role. And when we talk about behavioral sensing, we basically mean passive monitoring technologies such as sensors that can be placed in the home, as well as wearable technologies. And one of the advantages of passive monitoring is that they often can be installed in the residential infrastructure, for example, without requiring a user to learn to operate new hardware or software, which can be critical when we deal with populations that may not have experience with technology or are experiencing cognitive or physical limitations. The vision with behavioral sensing is to create systems that allow us to objectively, remotely, and continuously measure aspects of patient physiology, behavior, and symptoms. This gives us the opportunity to capture behaviors and activities of daily living without having to rely on human observers, which can be quite unrealistic and costly, and also allows us to monitor people in the real-world environment where they live, rather than in a laboratory, and can monitor people continuously rather than episodically during clinical encounters. One example is when trying to understand sleep quality, where assessing sleep in somebody's own home environment is very different from having a sleep study in a laboratory where people come in for just one night out of the year and they get wired with a lot of cables, and in that artificial environment are asked to sleep for a night. The goal with behavioral sensing data is obviously not to have a human at the other end look at the data in real time. Instead, we're trying to develop the right algorithms and use artificial intelligence to be able to understand and predict patterns of activities of daily living, identify patterns that could lead to emergencies, so we can actually address adverse events before they occur. And basically, we're talking about shifting from a reactive to a proactive model. Right now, in many health systems, we expect the adverse event to happen, for example, a fall, and then try to minimize the side effects, rather than perhaps have a system in place that allows us to prevent the adverse event from even happening. In that context, we see a lot of efforts with so-called smart home technologies. The term smart home in the 80s was used to refer to energy-efficient buildings, but now we see that they can play a role in health and health monitoring and wellness. And so we define smart homes broadly as a residence with embedded technology that facilitates passive monitoring of residents to enhance their safety, independence, and well-being. So imagine different sensors, motion sensors that detect motion, door and window sensors that can tell you when a door has been opened or closed, bed sensors that can detect restlessness at night, respiration, capturing sleep interruptions, bathroom visits, stove sensors that can provide information about meal preparation. All these sensors can actually provide insight into activities of daily living, with a goal to detect when things seem to perhaps deviate from what would be the normal pattern for an individual resident. For example, an increase in time spent alone, an increased time without visitors inside the apartment, less time spent moving around, more sedentary behavior, less time spent in meal preparation, poor sleep quality, increased number of bathroom visits. All those could be information that's very valuable, especially when we're dealing with older adults who are experiencing cognitive impairment, but are trying to maintain their independence. I will present to you a project we have here at the University of Pennsylvania that does use AI to promote a fall risk assessment and fall prevention intervention that we are targeting specifically for vulnerable older adults with mild cognitive impairment. The project is called Sense for Safety, and it's using technology to actually facilitate fall risk and fall prevention. Again, it's not focusing so much on the detection of the adverse event, but rather using the data to hopefully prevent the event from even happening. We're focusing on falls because that's clearly a critical issue in gerontology. Falls in older adults are the result of accumulated vulnerabilities, and cognitive impairment is a leading risk factor. So we are looking at older adults with mild cognitive impairment, which is a high-risk group. Over 60% of older adults with mild cognitive impairment will fall annually, and that's at a much higher rate compared to those without cognitive impairment. And similarly, we're looking at socially vulnerable older adults who live alone because that is also a high risk for falling. Older adults living in low-resource neighborhoods with poor housing conditions have twice the risk of falling. With Sense for Safety, we use technology to link older adults at home with a nurse telecoach who guides them in implementing evidence-based, individualized plans to reduce fall risk. The technology allows us to identify escalating risks for falls real time, and we are using machine learning and other AI features to inform individualized information about fall risk. The technology we use is a depth sensor, like the one you see in the picture. Depth sensors have often been used also in the gaming industry, but they allow us to create a silhouette extraction of an individual and ultimately calculate gait-related features, such as stride length or gait speed, that can be all used to calculate an individual's fall risk score. So here's an example of the type of silhouette extraction that happens with depth sensors. As we place them in the home, we usually place them in a room where we can capture at least one walk. And as residents walk around in their homes, we are able to calculate characteristics of their gait. The system also generates fall alerts so that if a fall is detected, the coach and as well as clinical or other contact individuals receive a notification with also the last 20 seconds prior to the fall, such as the one you see here. And that allows the person to actually detect if it's a false positive, or if it is a true fall before they actually initiate an emergency response. The data that we get for the from the depth sensors allow us to calculate the fall risk score for the individual so that the coach can actually provide tailored interventions for older adults. When they see that an individual has an increased fall risk score, they can provide individualized exercise programs, such as the Otago exercise, which has been tested for people with mild cognitive impairment as well as dementia, and also provide recommendations for home modifications. Some of those can be low cost, for example, removing rugs or tripping hazards in the home. And those can be especially critical when we look at this in the context of the individual's gait data. In our current study, we have enrolled 80 participants who are in the community. They live alone. They have mild cognitive impairment. All are over the age of 65, and they live in low-income housing, so they're socially vulnerable older adults, and therefore at higher risk for falling. We have our participants for 1 year, and one of the assessments we perform, in addition to having them live with a depth sensor for a year and doing those coaching sessions, is to actually have a human expert go into their homes regularly to perform some clinical assessments, with the goal to compare how the clinical assessment compares to that's technology-mediated or AI-mediated performance assessments. We are using the short physical performance battery test, which is providing us an objective assessment of lower extremity functioning among older adults, and scores from 0 to 12, with higher scores indicating better low extremity function. So we have the human expert visit the home and the resident every 3 months, and we compare those SPPB scores to the ones captured by the sensing system. What we have found is that the total SPPB scores by human experts and the sensor systems are highly correlated. Here you can see some examples. On the left is an individual with a very low SPPB score, which means that they have limited mobility and need significant assistance in ambulating around their home. In the middle, you see an individual who has an SPB score between 3 and 4, which means that they still need some assistance to move around and have experiencing some challenges in their mobility. And then on the right, you see an individual with an SPBB score of 6 or higher. That's an individual who has no or very few challenges in ambulating, and they're pretty independent in moving around. Having a system that can automatically do those classifications rather than relying on continuous expert assessment by having the expert visit regularly, which is something that currently does not happen in our healthcare system, can allow us to have a more proactive system as we see changes in gait on a continuous basis and in the real world environment where people live. We want that information to be actionable, and obviously visualizing data from gait can be a challenge. For the clinicians, we're developing dashboards that allow the clinician to annotate some of the information as they track gait characteristics such as stride length, average speed, stride time, and so forth over time for any individual patient or older adult that they're monitoring. It becomes more challenging when you want to visualize that information for the older adults themselves and their family members, especially because gait is not information that people intuitively know or is not as common or commonly discussed, like, let's say, blood pressure or other vital signs. So how to visualize this in a way that's acceptable, accessible, and actionable for the older adult users is a challenge. Here you see an example of one of our dashboard prototypes, and that's clearly work in progress that we have to continue refining, given that different participants have different visualization needs, different experience with data. In this work, and I think this is important for other applications as we think about the use of AI for older adults, is to recognize the role of the family member or friend who we like to call the trusted other. In most of our cases, in our studies, participants invite a family member, if they identify somebody or a friend, to participate as a dyad. And in this specific intervention, Sense for Safety, the family caregiver or trusted other can play a crucial role by receiving alerts and seeing that as peace of mind, knowing that their loved one who lives alone is safe, and also playing a role as an advocate for the coach when they're trying to reinforce environmental modifications or exercise recommendations. I've presented one example of AI use specifically for fall prevention. There's obviously a lot more applications that have a potential role, especially when we think about community living and older adults with cognitive impairment. A significant challenge that has been identified globally is that of social isolation and loneliness. And obviously, older adults who live alone and experience cognitive impairment are at an even higher risk of experiencing high levels of isolation and loneliness. AI tools can provide opportunities to create smart communities that promote engagement. And again, passive sensing could play a role in identifying patterns of isolation and loneliness. And we see a lot of work happening with large language models nowadays and generative AI. But even before this rise of LLMs, we saw conversational agents and chatbots potentially playing a role for isolated older adults. On the right, you see an example of the robotic seal Paro that's been developed out of Japan and has been since deployed in a lot of facilities and retirement communities and nursing homes. It provides an opportunity for the user to engage with this robotic pet, learn its likes and dislikes, and similarly, the pet uses some built-in sensors to showcase certain behaviors and also learn some of the characteristics in the interaction with the user. And there is evidence that shows that those types of technologies can actually reduce anxiety or even address agitated behavior for older adults with cognitive impairment. Similarly, other types of conversational agents could play a role in behavior change or providing connectedness and digital companionship. As we think about the use of AI for older adults, especially in the dementia space, we have to address the concept of obtrusiveness. Sometimes people will say passive sensing is non-obtrusive because it doesn't require the user to operate any hardware and software. And while that's true, I think obtrusiveness is a much broader term. We define it as a summary evaluation by the user based on characteristics or effects associated with the technology that are perceived as undesirable and physically or psychologically prominent. So what that means is that obtrusiveness includes a multitude of underlying constructs. We have to think about the physical dimension of the technology, the hardware that's being used, and how it integrates into the home environment, aesthetically and physically. We have to think about the usability and whether end users can easily access information on dashboards or however else the system may interface with the user. The privacy dimension is critical as we think about introducing technologies in the most sacred of spaces, our own home. We have to understand the function dimension and whether the technology performs as expected. And the problem with false positives, for example, in fall alerts, can be costly, both psychologically and financially. And users need to be able to trust the systems that they have introduced into their homes. We have to think about the human interaction dimension as we think about AI in gerontology and geriatrics. Many of our older adult participants talk about technology as a potential threat to replace in-person visits or contacts that could lead to a lack of human response and may indeed negatively affect human relationships. We have to understand how the technology affects self-concept. Oftentimes, people who have special technology to promote aging in place may see that technology as stigmatizing or a symbol of loss of independence. How does this technology interfere with daily routines, and do people need to acquire new rituals to accommodate the technology use? And finally, how do we sustain these technologies? This is a concern about affordability, but also the ability to still learn and use a technology, learn to rely on it, and be able to use it years down the road without knowing whether people may be experiencing financial, cognitive, or physical changes that may make that sustainability challenge even more challenging. So clearly, as we try to evaluate these technologies for their obtrusiveness, there is a multitude of parameters and factors that we have to address. Additionally, we need to ensure that the technology does not exacerbate existing health disparities, that people are fully aware of the risks and the benefits as they sign up for these technologies, which can be a challenge, especially when we talk about older adults with cognitive impairment. That requires a patient education component, a better understanding of patient and family preferences, understanding that the introduction of AI tools does change the process of healthcare delivery and will ultimately impact the workflow of clinicians and even the clinician-patient relationship. We need to ensure that we don't introduce technologies that perhaps cause conflict between preferences that the older adult may have and their families. And we need to balance the need to keep people safe with their own preferences for privacy and data sharing. And clearly, the AI tools are introducing opportunities to enhance the social aspects of care in addition to the more traditional physical and physiological aspects of care. Finally, I want to briefly mention an initiative we have here at Penn called Penn AI Tech. It's the Penn Artificial Intelligence and Technology Collaboratory for Healthy Aging, which facilitates a national grant program to promote the use of artificial intelligence in aging and for people with Alzheimer's disease and related dementias. And I invite you all to familiarize yourselves and learn more about our initiative. We would love to hear from you. I'm also happy to answer any questions, or if you need more information, please feel free to contact me at this address. And I want to thank you for your attention.